Okay, this is college algebra. We're still in section 2.4a and 2.4b, and we're continuing with the third method for solving a quadratic equation called completing the square. So completing the square, we have all the steps written out here. I'm going to verbalize those steps, but you have them in print even after I finish the problem. We're going to do two different problems. This one's going to be harder again because the a value is 1 here. Those are always the more simplistic procedures. And then when that a value gets bigger than 1, that always adds a couple more steps to whatever method you're using. So let's see. So completing the square. Very first step that you're going to do is you're going to isolate the squared term and the linear term on one side while moving the constant to the other side. So this will be step 1. And what you're going to try and do to these two terms is turn it into a trinomial by completing the square. The way that you complete the square is you perform a series of 2 steps on this linear term, first degree term. And that is, one thing you're going to do is cut that coefficient in half. Half of -6 is -3. And then the second thing you're going to do there to complete the square is square this number, resulting in a 9. So now you have a trinomial, but pay attention to what you added brand new to this problem that wasn't in the original problem. You added 9 on the left, therefore you have to counterbalance the right side of the equation by doing the same operation. So this is what gets you the number that creates a perfect square trinomial. Once you get this perfect square trinomial, you are then going to factor. And the reason that you're going to factor, by the way, there's a shortcut always for factoring perfect square trinomials. They always come out looking like this. This is a shortcut. By the time you factor it, even if you did it the long way by guess and check, because that would be possible here because the a value is 1, they always end up where what's in the 2 parentheses is exactly the same. You have 2 of the same thing, and that's the same thing as saying I have that quantity squared. Anything times itself can be written as a square. So when you get done factoring, it's going to look like this anyway, so you can go for this, and I'm going to show you how to fill in the front as well as the back. What you're doing to fill out the front is you're taking the square root of this first term, which is x. If you were to take the square root of this term, it would knock off the square, leaving you with just an x. Then you're going to take the square root of this back term, that number that you created, and that would be 3. Then you're going to join these 2 terms by the sign in front of the linear term. And there it is, all factored. Let's see what we have on the other side. We had a -4, which came from moving that +4 to the right-hand side. And we had a brand new 9, which was used to counterbalance the right side because I added a 9 over here. So those 2 together is equal to 5. I'm going to bring this up here and continue with the solving step. So at this point, I have x minus 3 squared. So this becomes like the previous problem where you had an entire binomial with a square on it. But it's nice and clean. It doesn't have any multipliers. It doesn't have any additional things being added or subtracted. So you are ready to go into that square root property. And we had a 5 on the right. So here I go, trying to get rid of the square by using the opposite operation, which is the square root. I'm going to do the same thing over here, but remember to report both the positive and negative root, because when you're using the square root property, that is what gets you the 2 answers. All second degree should have 2 answers. And although when you're factoring it, the 2 factors give you the 2 answers. But here it's obtained by plus or minus. By the way, anytime you're taking a root of an even-powered expression, that is when you'll always have the plus or minus. Like if this was a 3 and you were taking a cube root to get rid of it, you would not have two different roots. Odd roots only have one answer. So anyway, just a little background on that. This square root wipes out the square, and out comes this base. And by the time you're as soon as you get rid of that square, you can drop the parentheses. That's why I'm writing it like that. Let's not forget to write our plus or minus, and there is no square root of 5. Okay, so you're going to have to leave that entire 5 underneath there, but do remember that you need to isolate the x in order for this to be finished, in order for you to have a full, complete solution. So we're going to bring this 3 over here. It's going to appear as a negative 3 on the other side and is no longer here. So then you have x equal to negative 3, like I said, standard form for these kind of answers that are part integer and part radical is the integer is written first and then the radical. I don't think they'll care which piece you write first in My Open Math. Every software has its idiosyncrasies, but it's just a standard way of writing it. So if you want to write it as two separate answers, you could write the negative 3. That's not going to change. This is what changes, the sign in the middle. Plus square root of 5, that would be one solution if you want to list each one separately and separate them by commas. And the other solution would be negative 3, but this time I'm going to use the minus sign in front of the square root. And those are two completely different values. Okay, so that one's done. Now, again, just getting you ready. This one has more steps because you are not allowed to complete the square until you have a nice clean coefficient of 1, not a 9. So the a value must be 1. Must be 1. And that's what we have to start this problem off, by achieving that. So again, we're going to do the same things that we did to start this one. We're going to move the constant to this side, thus creating a positive 4. This is no longer here. And what you're working on is 9x squared minus 6x. You may not complete the square, cutting in half and squaring. You can't do that until you factor out this leading coefficient of 9. You're not going to do a full-blown factoring. I get that there's an x that's common to both. You're not looking to do that. You just want to factor out this 9 so that it has a coefficient of 1, and then you can complete the square. Okay, so I'm going to take out a 9, put a single parenthesis next to this factor that I'm taking out, and get back each one of these. Okay, so 9 times what is 9x squared? X squared. 9 times x squared is 9x squared. And 9 times what is negative 6x? I know that it's 2/3. I can tell you a shortcut for figuring out what that fraction is. You'd have to multiply 9 times negative 2/3 to get a negative 6. And if you put that in your calculator, you'll see. And let me write the rest of this before I go off using the calculator. And I shouldn't have closed that. I should have left it open so that I can complete the square. Okay, so this times this is 9x squared. This times this is negative 6. Don't forget, you're leaving room to come up with that third term so that it is a perfect square trinomial. Presently, what I have on the right-hand side is positive 4. Okay, so just wanted to show you that 9 times negative 2/3 is negative 6, and then I'm going to explain to you a shortcut for how to get the fractional part. So 9 times negative 2 divided by 3, and if you just hit enter, you're going to see that it is negative 6, just like we wanted. We wanted 9 times what equals negative 6. So what you could do is you could just take the linear coefficient over the 9, which is 6/9, and you'll see that 6 Negative 6 divided by 9 is this fractional portion that you're looking for, because a lot of students will, how do you get the fraction? So it's a simple way to figure out, hey, what fraction should I multiply the number by that I pulled out in order to get this middle term? So this will get it for you. This coefficient over this coefficient, and I'll demonstrate that to you. Negative 6 divided by 9. Again, placing this on top of this as a fraction. And then if you go math, enter, enter, that's how you reduce fractions. You'll see that that's negative 2/3. Math key, and then enter twice. Hit the enter button twice. See, that's the fraction that I needed to multiply this 9 by to create the negative 6. Okay, now we can finally go into completing the square steps so that we can come up with this third term and have a perfect square trinomial. So we're going to do half of the negative 2/3. The 2's will cancel, and you'll be left with negative times 1, negative 1 over 3. And don't forget that whatever you get when you take this number and cut it in half, you also have to square it. So at that point, you have negative 1 squared is negative 1 times negative 1, 1. And then 3 squared, you got to square the top as well as the bottom, is 9. Okay, so that's the number that you're going to be adding right in here. Okay, now you've created a perfect square trinomial. And the next thing you do is go into the factoring step. So now we're on to the factoring step, and I was telling you that all perfect square trinomials end up factoring where you have a binomial times the same binomial. So rather than writing it out twice and then calling it the binomial squared, you can just go ahead and jump right into that. And to fill out the front, just take the square root of this squared item. Square root of x squared is x. And also take the square root of this last item. The front item and the last item. That's what fills out the front and the back. Okay, square root of 1/9. You have to take the square root of the top, then the square root of the bottom. Square root of 1 is 1. And square root of this bottom number is 3. And then you join these two terms by the sign in front of the linear term, and you got it factored with hardly any work at all. Okay, let's talk about what we have on the right-hand side. This typically messes students up, so I'm going to explain it in detail. Remember how in this problem, when this one was much more simplistic, when we finally did create this 9 that helped us create a perfect square trinomial, we then realized that, yeah, we had moved the 4 and it was a negative 4, but we realized that whatever we added here, we also had to add here. Now this is harder, this problem, because there's fractions involved here and you've pulled out a 9. So I know you're going to want to do things, this is very common, like, hey, what do I add to both sides? Ooh, it's a 1/9, I'm going to add 1/9 here. But keep in mind that this is impacted by this multiplier. So what you really created on this left-hand side that wasn't in the original problem is 1/9 times 9. Now, if you don't know that that's 1, you're going to have to, to figure out what to add on this side so that it counterbalances what you've added on the left. It's always this fraction times that fraction. If you don't know that that's a 1, put it in your calculator. 9 times, let's see, and that is a 1/9 times 1 divided by 9. That's how you make a fraction. Just push 1 divided by 9, press enter, you see that's a 1. So what you really added on this side is a positive 1, and therefore you're going to add a positive 1 to this side as well. So as I finish this problem, I have what's on the left side, but all of this is in factored form. And let's see. I had just factored this perfect square trinomial. Don't forget that there was a 9 out there. And what I have over here is 5. I have 4 plus 1 is 5. There was a 9. This is this trinomial is this squared, but you got to remember to copy down the 9 so you have exactly what you have here, but in factored form. Okay, now what we're going to do before we get rid of that square is we're going to divide off this multiplier, because you remember you don't get rid of a square root until you have a nice clean one in front of the squared expression. So this will get rid of this, leaving me with x minus 1/3. Now this problem is no joke. And if you've divided by 9 on this side, you need to divide by 9 on this side. Okay, how do I divide by 9? Well, you can put it in the calculator just like that if you want to, without, going nuts and doing any transformations. You can just feed it in just like that and let the calculator do it for you. 5 divided by 9, divided by 9, and instead of pressing enter, I think I might have to put this in parentheses. I'm going to go 5 divided by 9, close it off so it knows that that belongs to that, and then divided by 9 once again. And then instead of pressing enter, press math. Oops, I pressed the second one. Press math. That's that third key down in the first column. So press that, and then press enter twice. And it'll do the arithmetic and simplify it. Okay, so it just did all of this for you, which was 5 over 81. Okay, so this came down. I got rid of the square root. No, this was still like this. I didn't do the square root yet. All I did was divide by 9 on both sides, so I got rid of the 9 that was there. And therefore I had to divide by 9 on this side. Then I'm left with this, and now I'm ready to jump into taking the square root. I take the square root of this side, I take the square root of the numeric side, remembering to report both the positive and the negative root. So let's finish it out here. On the left-hand side, this square root abolishes the square, and out comes this base. This is a crazy long problem, but some of them are hard. I don't know if you're even going to have one this hard in My Open Math, but most college algebra courses, it's in the software. You'll have to look in Mom, just getting you prepared for anything. Plus or minus, square root of this, can't take the square root of what's on the top, the 5, so it stays like that. But you can take the square root of 81. Square root of 81 is 9. And you're still not finished, unfortunately. You still have to isolate this x by adding 1/3 and adding 1/3. So x is equal to 1/3 plus or minus square root of 5 over 9. Now I believe they're going to want you to get a common denominator here. I mean, if they don't, cool, put it in like this into Mom. If they do make you report a common denominator, you would just want to turn this into a 9. You turn denominators into whatever you want through multiplication. Whatever you do to the bottom, you'd have to do to the top. So this would be 3 over 9 plus or minus square root of 5 over 9. And you'll have to see whether they want it as two separate terms, two separate fractions, or whether they want it as just one fraction. Because these have the same denominator, you now have the option of pulling them together into a single fraction. That's always an option when the denominators are the same. You put these numerators on the top, connected by the plus or minus, so 3 plus or minus square root of 5, and that common denominator, you just mention it once. You don't add them up or subtract them. Okay, so that completes the method of completing the square. We are now on to solving the equation by the quadratic formula. It's hard to forget this because it comes up in every algebra course, and it is, you don't have to do a lot of number matching or finding combinations that multiply to give you the C and add to give you the B. This is just a formula that you um, press these numbers into. This is A, this is B, and this is C. And the formula is the solutions for X are change the sign on the B. That's what negative B means, opposite of the B value. And then it's plus or minus to get two answers. B squared minus 4 times A times C all over 2A. Okay, so I'm going to start putting those numbers in. Opposite of the B value, well, the B value is 2, so I'm going to show opposite sign of the 2. It was a positive 2, now it's a negative 2. Then your plus or minus. Let's put what's underneath the radical, and we'll slowly work to whittle that down. But it's going to be B squared, so 2 squared is 4, minus 4 times A. Make sure and show you this work. I did part of it in my head. I did the squaring the B part right here. And then it's 4 times A times C. Just follow that formula right there. And you need to use the signs that are in front of these A, B, and C values as you plop them into any kind of a formula. And this is all of this is going to be over 2 times A. So 2 times A is 16. Now for the rest of this, we're going to be simplifying it. So X is equal to negative 2 plus or minus. And then here, I'm going to do some of the work over here so I don't have to keep copying it over and over again. This is actually what's underneath this radical is going to be 4. And then let's see, negative times negative would be positive. So 4 times 8 is 32, and then times 1 is still 32. But it is going to be positive because you've got a negative times another negative down the way. So 4 plus 32 means we have a 36 as a single number underneath that radical. And don't forget, all of this is over 16. Let's keep going. So X is equal to negative 2 plus or minus square root of 36, which happens to be a 6, all over 16. Okay, I'll use up this remaining space, and it is X is equal to, let's do some of this now, negative 2 plus 6, which would be 4 over 16, and that reduces to 1/4. So that's one of your answers. Other answer is negative 2 minus 6. So at one point you're going negative 2 and using this top sign. Negative 2 plus 6 gave us the 4. And now I'm going negative 2 minus 6. And that combined with a negative 6 is negative 8. And don't forget the bottom is a 16. That leads us into our second answer, which is negative 1/2. Okay? So 1/4 and negative 1/2. Okay, so that finishes the first quadratic formula problem. Now let's move on. We're not doing too much of this because it's just too simplistic compared to you picking out what factoring method to use or the intricate steps involved when you're using square root property. Those are procedures that you have to be familiar with the order of the steps, and also completing the squares the same way. There's an order in which you do the steps. Whereas this, there's no order. You just plug them in and you get the two answers if you can, wrap your head around simplifying it at each stage. Okay, we move to the last concept now in this outline. And this is going to complete 2.4a and b. You see here that these are rational expressions. In other words, the denominators have expressions containing x. So if even one of the denominators has an x, in order to solve for x, you're going to have to clear out those fractions. You can't solve for x while they're down here in the denominator. So We want to practice the idea of forming a least common denominator, because once we make a decision on what the least common denominator is, we're going to multiply everything here by this LCD, and that's going to wipe out all the fractions so that you can go about the business of finish, so that you can finish solving. Okay, so one of the easiest ways I can tell you to look at to form the proper LCD, the only expression that's going to cancel out, or the smallest expression anyway, that's why it's called least common denominator, is to throw in one of each of these denominators. So you're going to throw in a 4 and x, I'll put that next, and I'll put this binomial here at the end, just looks better. Okay, so this is your LCD, because you want to have an LCD that's strong enough that in one case it's going to knock out the x, in one case it's going to knock out the x plus 3, and in one case it's going to knock out the 4. So throwing each one of these denominators into your LCD will accomplish that for you. Close off the whole equation and throw that LCD out front. It's going to act as a multiplier. Okay, so we're going to multiply all of this times 1 over x, and just visually we'll talk about what cancels and what remains. So when you multiply all of this times 1 over x, notice that this x is in the bottom while this x is up top. So that x is going to cancel with that, and now what I'm going to report is all the things that didn't cancel, that didn't go away. There's a 4 left, times x plus 3 times 1. All the things that are left over, you just report them as a product. So this times 1. Multiplying by 1 is not going to change anything, so we'll just write it like this. These are the things that didn't cancel with anything. Now we're going to do the next product. And now we're multiplying that same LCD, but by this. Notice that this x minus 3 cancels with this x minus 3, but don't start striking things out here, because every time you go to multiply, you're using the entire LCD. So let's get rid of that little mark so it's nice and clear. This was a 4 with an x, and then an x plus 3. So I'm not going to put any marks here. I had a mark there. So I can remember that I'm using this entire thing each time I multiply. So here, just visually, this x plus 3 cancels with x plus 3, and what would be left is 4 times x times the numerator. You're always multiplying by that numerator, and sometimes it's not a 1, so remember to multiply by the numerator. So this 4 times x, because those would cancel. Bring that plus sign down and report what's left over after considering that x plus 3 cancels with x plus 3. Now use it finally on the last term. You need to multiply it by each term, whether they're fractions or not. Okay, so when I multiply all of this times this 4 would cancel with this 4, leaving x times x plus 3 times 1. X times x plus 3 times 1. So now you at least don't have any fractions, but you do have a quadratic equation. You have a second degree term here, which is going to force you to use one of the methods that you learned in all the previous pages. And those were, once again, factoring, square root property, let's see, completing the square. That was the third method, using quadratic formula. I just showed you and demonstrated 4 different methods at different levels, and this is what is you're going to be able to just make a choice. Hold on, I got to plug in my charger. Okay, there we go. All right, so you can pick the method you're going to use, but first let's get the quadratic equation and get everything on one side. Because I think, you know, the most common things that students either use factoring or they use the quadratic formula. Those are the ones that students are most comfortable with. Factoring is shorter, it's less work because there's a lot of things to plug in for the quadratic formula and a lot of things to simplify. So let's see. Over on this side we have 4 times x. That's going to be 4x. Don't forget to multiply by the 4 by the 3 as well. That gives you 12. Dump down that 4x. Bring down the equal sign. Once again, distribute. X times x is x squared, and x times 3 is 3x. Okay, now you want to get everything on one side, and if the squared term is positive, right where it's sitting, leave it there and bring all these things over to the right-hand side. Got to zero out one of the sides to use quadratic formula or factoring. All right, so what we have here is 8x, positive 8x. By the time it comes over here, it is negative 8x. And you could take them over one at a time, but I just take it over once by combining them first, realizing what the sign is on that combination, and then switching it. And then if we bring this over here, it's negative 12. So everything has now moved to the right-hand side. You have a 0 here, just like you need for either of those solving techniques. And what we have here is our squared term, which makes it a quadratic equation. These two combined is negative 5x, and then we have negative 12. Now, we might not even be able to factor this, because you can use guess and check simply because this only has a 1 in front of the squared term, but there might not be any numbers that multiply to give you negative 12, but then add to give you the b value. This is c value, this is the b value. That b value is negative 5, so think about it. Ways that you can get a 12, you can use 4 and 3. In no way are you going to get a 5, even if you mess around with the signs with a 4 and a 3. You could use 6 and 2, but one of them has to be negative because you're trying to get a negative 12, so in no way with the 6 and 2 are you going to get a 5. The only other option is 12 and 1. One of them is going to be negative. There's no way you're going to get a negative 5. So this does not work, therefore it does not factor. And when something does not factor, you must resort to the quadratic formula. Okay, so we're going to use quadratic formula because I couldn't find any number combinations that would allow me to factor it. So with the quadratic formula, x is going to be equal to opposite of b. Let me move this down a little bit. I'm going to run right into my work. X is equal to opposite of the b value. This is my b value. This is my a value. And all of this, just like all of this is the b value, is my c value. You need to be very aware of what a, b, and c is so you can plug it in properly. So it's opposite of b. That means switch that sign. So you have a positive 5 here, then plus or minus goes the formula. Then underneath the radical is b squared. So anything squared is positive. Negative 5 times negative 5, that's what it means to square something, is positive 25 minus 4 times a times c. All of that is underneath the radical, and then the quadratic formula goes 2 times a on the bottom. So 2 times a would be 2 times 1, and that would be a 2. Now we're going to try and simplify what's underneath here. So underneath the radical, we would have 25 minus, we just do a little work before I copy it again. Let's see. Negative 4 times negative 12, that would be positive 48. So let's change this to a positive 48 because you have a negative here times another negative down the road, which results in a positive 48. So doing a little bit of arithmetic right up underneath this radical, I have a 25 added to a 48. You can put that in your calculator. And you get 73. So this is equal to 5 plus or minus square root of 73. That's what all of that simplifies to, over 2. And you can, again, you can say these as two separate answers if that's what's asked for in My Open Math. You could say 5 plus, by the way, if there's no square root for the number 73, No way to break it down. None of the numbers from the square root. Let's divide into this. So that's as good as it gets. That number has to be left under there. And if you want to give these answers one at a time, it would be 5 plus square root of 73 over 2. And sometimes they even get creepy and want you to take that and separate it. So if they start asking you to, or imply by marking your answer wrong, that they need two separate terms for this, then break it into two terms, each term having this as a denominator. So this is the same thing as the answer that I just wrote. And then the other answer here is 5 minus the square root of 73 over 2. And again, that can also be split up into two fractions. It would be this over 2. 5 over 2 minus square root of 73 over 2. Whew, exhausting, this section. A lot of techniques. All right, so this is really two sections in My Open Math, but in the old book that we used, all of these were just called another section, but they were all the same exact topics. So here we go with the last problem. So remember, first we need to come up with the LCD that we're going to multiply all of this by so that we don't have fractions. You're going to throw in one of each different kind of denominator that you encounter. You're going to put all the different factors. So all you have here is just an x minus 5, so you're going to throw that into your LCD. And your LCD is formed as a product. Here you have a different denominator. You're going to throw that into your LCD. And then here, let's see if there's anything new that I haven't already listed as part of the LCD hiding inside of this. You've got a factor to tell what the factors are that created this. Okay, this is the difference of squares. That is factored by taking the square root of this. Just want to reveal what's hiding inside of that and the square root of that. And then you separate, and then you alternate the sign. So square root of x squared, square root of x squared is x. That fills in the front position of each of these parentheses. And then square root of 5 of 25 is 5, and then you alternate the sign. One can be plus, one can be minus. Now upon factoring that down, I see that nothing new is created here by factoring. Nothing new as far as expressions go that isn't already in this LCD. So the LCD is x minus 5, x plus 5. Let's say you had broken this down and one of the factors just upon factoring was, let's say, an x plus 2. That would be brand new, hasn't been put in the LCD, so you'd throw in that factor as well. But in the end game, this ends up being our LCD. Okay, just x plus 5, doesn't matter which one you list first, times x minus 5. Okay, we're going to imagine multiplying that LCD. And imagine it, we're going to actually do it times each of these terms. Times this, and times that. So when you multiply this LCD by 2x over x minus 5, you have an x minus 5 here in the denominator and an x minus 5 up here. So these cancel, leaving you with the numerator times the piece or the factor that didn't cancel. So just the x minus 5's cancel. You're left with 2x. You state the leftovers as a product times x plus 5. Okay, when you multiply this LCD, still out here, by the next fraction, this x plus 5 would cancel with this x plus 5, and you'd have 3 times x minus 5 left over. Bring down that plus sign. 3 times x minus 5. These would be the things that didn't cancel with anything. Last product, you're going to multiply this LCD one more time, but times the fraction on the right-hand side. So each factor in this LCD is going to knock out both of these factors. The x plus 5 knocks out the x plus 5. The x minus 5 cancels that away. And so all that's left is nothing here, but just that numerator, this negative 21. So at least you don't have fractions anymore, but you do have to multiply this out and decide how you're going to solve for x, because you are going to end up with a quadratic equation. And here is it right here. You have 2x squared and then plus 10x. And then here you have 3 times x minus 15. And then we do need to zero this out, so I'm going to bring this number over to the left side, at which point it becomes positive 21, and you have zeroed it out. Okay, combine like terms for a neater, simpler equation. We only have one squared term. We have two linear terms, so you can combine those. And then here when we add these two, we have negative 15 combined with 21, which ultimately makes you subtract. So the difference between these two is positive 6. That's equal to 0. And then we're going to just pick a method that we want to use to finish this problem. You can use quadratic formula. You can use factoring. But this would be split the middle term, so I think I'm going to go with quadratic formula in this case. Too many steps, but sometimes necessary. So again, this is A, this is B, this is C. Formula goes opposite sign of the B value, so negative 13, plus or minus the B value squared. 13 squared is 169. You can go ahead and do that in your calculator if you want to. If you don't know that, but it is 169. Okay, so that's b squared. The rest of the formula in here goes minus 4 times a, the a value is 2, times c. The c value is 6. And don't forget, the formula has a denominator, which is 2 times the a value. And memorize that formula if you're going to use it. So it's negative 13 plus or minus, and we'll whittle this down a little bit. Let's see what this back number is that we're subtracting from 169. So this would be 4 times 2 is 8. 8 times 6 is 48. So we're going to be subtracting 48 from the front number. Okay, so 169 minus 48. And I get 121. That's good, so that's a perfect square. There actually is a square root of this. So you don't have to break it down and do a partial square root, because this is 11 squared. Therefore, the square root of 121 is 11. You can pop that in your calculator, and the bottom is a 4. Let's keep going. Negative 13 out front, followed by plus or minus. Square root of this is 11, and ultimately that sum as well as the difference gets divided by 4. So carefully, that sign doesn't change, but you're going to have different signs for each of your answers in the middle. So first I'm going to use the plus sign, so I'll be adding plus 11 for the denominator of 4. And that's going to give me negative 13 plus 11 is negative 2 over 4, which when reduced is negative 1/2. You can always get your calculator, but I think most of you can reduce that in your head. Okay, then the second answer is, this doesn't change. The front number doesn't change with respect to sign. But this time, oops, I didn't carry that plus or minus over. Oh, okay, yeah, I already was breaking it up. Here I had the plus or minus, and here I'm already using one of the signs at a time. So negative 13 now minus 11 rather than positive 11. And then over 4. So when you combine this with this, you're just going to get another negative number. When they're the same sign, you can just add up these numbers. 11 and 13 is 24. And because both of these numbers are negative, that 24 is negative. Again, you can put that in your calculator. If you're going to put this in the calculator and the first number is negative, you must attach it with this symbol right here. Do you see that down at the bottom of the calculator? There's this minus. That's if the front number is negative. So you would go negative 13, if you didn't know this was negative 24, negative 13, there's a negative on the front number, then the regular minus sign for the second number that's negative. Okay, you get that, and of course that divisor is a 4, just like this one. Negative 24 divided by 4 is negative 6, and that is the second answer. So all equations that have two answers, and we have looked at how to solve the quadratic equation that was given to us, and just from originally, or in this case, just clearing out the fractions created quadratic equations, and then you have the choice to pick whatever you want as the method for solving. Okay, that completes sections 2.4a and 2.4b.